Welcome to Hartman Math. This is lesson 8.5, Applications of Matrices and Determinants. We're going to begin with Cramer's rule, which is another way of using matrices to solve a system of equations. So what it says is that your first solution, whether this be x, y, z, whatever, but your first solution, and we typically think in terms of 2x2 or 3x3 systems, so this essentially would be x, would be the determinant of what we'll call the x replaced matrix, or the first replaced matrix, divided by the determinant of the original matrix, and so on for y and z, or maybe we're doing w, x, y, and z. It doesn't really matter. So it's just finding a lot of determinants and finding their ratios. So let's see what that looks like. It does, however, it cannot find no solution or infinitely many, because what's going to happen is this one right here, the determinant of the original, if that one is 0, obviously we can't divide by 0, so it's not going to be able to find those. We would need to, if we came up with that result, we would need to find it by a different method. So we'll start with a 2x2 system, just kind of to get into what Cramer's rule looks like. And so the original determinant, so A bar's determinant of matrix A is 2, 5, negative 1, 2. And we'll say that's the coefficient matrix. So notice the bars to say we're finding the determinant. And remember, at 2x2 we can just do product minus product, so 4 minus negative 5 is 9. And then D sub x would be the x replaced matrix. So we're going to replace the x column, the 2 and the negative 1, with what we have over here, negative 1 and 5. So D sub x, I call it the x replaced matrix. And we're finding a determinant, so negative 2 minus 25 is negative 27. So once we know that, x would be d sub x divided by d. So negative 27 divided by 9, we just found out that x would be negative 3 for this system. Now we'll find d sub y. We'll replace the y column, the 5 and the 2, with negative 1 and 5. 10 minus 1 is 9, and therefore y would be 9 divided by 9. Y is 1, so our solution, negative 3 comma 1. And that's how we operate Cramer's rule. Checkpoint, use Cramer's rule to solve here. Pause here until you're ready. So we'll start with D, the coefficient matrix, finding the determinant. You get negative 15. D sub x is negative 5. Therefore, x is 1/3. D sub y is negative 75. So y is 5, and the solution that you should have gotten was 1/3, comma 5. Let's take a look at Cramer's rule to solve a 3x3 system. So the determinant of the coefficient matrix, notice we've got a little hole there, so we have a 0 there. So now with the 3x3, remembering to previous lesson where we're calculating determinants of larger ones, we're going to expand by a row or a column. I definitely want to use the 0, so I could easily go third row or third column to do that. Let's do the column. So negative 1, and remember our sign chart, positive, negative, positive, so it keeps the sign. Negative 1 times the remaining wipeout matrix there. 5, but it will turn negative 5, so the entry 5 times the negative 1 times the minor, the determinant, and lastly 0, which means we don't need that one, so we'll just do these. Negative 2 minus 6, negative 4 plus 3, 8 plus 5 is 13 is our original determinant of the coefficient matrix. D sub x, we're going to replace first column with 1, 8, 0. And now I don't have to do the same column. I could do any row or column for this one. I definitely want to use row number 3 there, because I'm only have to calculate one determinant here. So sign chart, positive, negative. So we're going to go negative, the opposite of negative 2 times a wipeout matrix. Determinant 5 minus negative 8. So 2 times 13 is 26. So as far as x is d sub x divided by d. X is 2. Let's now investigate d sub y. We're going to take this column and replace it with 1, 8, 0. Once again, I think we should expand by row 3. Positive, negative, positive. So keep 3 as positive. And here's what's left. 5 minus negative 8. So we get 39. D sub y divided by the original d, which was 13, leaves us with y is 3. D sub z, the original coefficient, replaced with 180. So back to, it really probably doesn't matter if we go here or here, but we definitely want to use the 0. Say we're going to go with the 1, that's a positive on the sign chart. Wipeout matrix, positive, negative. So we'll go minus 8 times. We're looking at negative 2 minus 6, negative 4, kind of same thing as we were looking at before, negative 4 plus 3. Get 0 there, so 0 divided by doesn't really matter. We're going to get z is 0, so our solution, x, y, z, 2, 3, 0, solution to the system. There's Cramer's rule. So another application of matrices and determinants is to find an area of a triangle where we know the vertices in the coordinate plane. So if we know the 3 coordinates, here, here, and here, we list those side by side, here, here, and here, with 1s for the 3rd column. And the area would be plus or minus 1/2 times that determinant. It can't be both. We're going to have to choose. So we're going to choose positive or negative based on this. We know area of the triangle needs to come out to be a positive number. So if the determinant is positive, we'll multiply by positive 1/2. If the determinant is negative, we'll multiply by negative 1/2 so that the area turns out to be positive. So here are our vertices of the triangle. Let's set this up. Area of the triangle is equal to 1 plus or minus 1/2 times the determinant. We'll stack those in columns with the 1s right here. So we're definitely going to choose with this row or column here to expand by. So we're going to go, let's go first row. So 0, don't have to worry about that one. Plus, minus, so minus negative 2 becomes 2. 3, 1, negative 5, 1 is what's left. Positive on the sign chart plus 1 times. So 3 plus 5, 24 plus 20. We get 16 plus 44. That's going to be positive, so we're going to multiply by positive 1/2. Half of 60 is our area of 30. Let's finish up with this checkpoint. Pause here until you find the area of the triangle. Here's our setup. Maybe expand by the third row. Negative 1/2. This time we're choosing negative, as the determinant came out to be negative 18. So we're choosing to multiply by negative 1/2. So we get an area of positive 9. That's it for today. See you next time.